And again, I only used that's 4 bits. That's 4 bits. So this is 1 byte of data. This plus this one would be 1 byte of data, but I just don't want to keep making up stuff as I'm going along. These could be in anything, whoever programmed it and gave the functionality. I'm just showing you what the bits could represent and how they're used in a processor. This would be in a memory map, and this would be 2. It'd be a 2C because that's 12. 8 plus 4 plus uh, you don't add the 2 or the 1. So 8, 4, 2, and 1. That's 15. So this is 12. 8 and 4 is 12. It's C. Time. I'll go over. Okay, now I'll go back to this one because this is the one that I ran earlier and I showed you everything went and I set and I got confused saying 32-bit and 16-bit. I changed it as 32-bit. I'll go to the log file that I have. I'll explore. I have a log file that I made for this thing, and right here, see it generates a log file every time I run it. Um, Actually, that one didn't generate. Oh, that's why. Why? Yeah, I think that's it right there. I think that's it right there. It's got to be the last one I ran. There's the log file right there. Yeah, 220. That. Let's just open that up. Take my time. 51 seconds. So it starts out at 220 and 224, 228. So now it's not really accessing it, but it can. You just have to know the command and you have to know how to do it. You have to be able to connect to a processor and do that kind of stuff. When I was at Alcatel, I was doing that. I've done that at several companies. I used to automate software to test electronics, and I can't do nothing because you won't tell the truth what you did to me at Alcatel and the on networks and FBI and everywhere I go. They're like, that didn't happen. Nobody would do that. So here's 8200 where it rolled over. So it gone all the way to FFFF, and then it went to 10000. And the next time it'd go up to 1FFF. It'd have a C, and then it would be a 10000. There we go. Here's the. This is the one I'm going to write. The one I have now. This one that I'm about to run. It'll record as CPU 0, 1, 2, and 3 because I have it doing a multi-state. Multi-state. It has 4 processors in it. The original one that I just ran for you it's for 1. It's built for 1. This is built for 1 processor, and I'm going to show you that it's going to generate a file. I'll do that really quick, just to show you that it works. I'm going to stop and restart so you can see it. I went over by like 8 seconds. Over by 8 seconds on that. Anyway, that's the log file. It shows you that it worked when I ran it. Now I'm going to go to how it can be used. This is the same program that I used for this one. Notice that it has a date and time stamp. So when I run it, it has a date and time stamp. Like that was last night I was working on this stuff too. You can see I was up till like midnight, past midnight. There we go. So I ran. This is when I ran. I'm going to show you that one in a minute. I wrote it last night, and I ran. I worked on this from about 8 o'clock yesterday until 12:35 midnight last night, and then I went to sleep, and I woke up and found a few bugs and kept going. So I'm gonna start and restart. And see now this computer is it doesn't have much memory or anything. Oh, come on, don't do that. Doesn't have much memory, so that's the file 8:16 a.m. and and you can tell because it's going to start with 220 and it's going to stop right here at 584, and we'll open it up. It's 220. At the bottom it stops right at 584. Plus it has the time and date stamp. Register access on 9/2/2023, 8 a.m. 8:16 a.m. 40 seconds. Um, that was the one I just ran, just so you know, because there it is 8 a.m. 16. Now I'm gonna go to the other one. The more to go to this one, it took a long time to write this one. Well, it took a long time to write this one that you just looked at. The other one is actually really easy because I just pasted four of them. It's really easy. Just after you do it once, it's really easy to do all four. I'm gonna stop and restart. And oh, close that down. Close. Go. Uh, this. And I'm just gonna show it to you, but it's not hard. Well, I shouldn't say it's not hard. It took a long time for me to figure out how to do it the right way. This time I used AND gates, and I did use the gates, and the gates do mean something. Um, and what I made sure of is it would work for a full set of registers, so it works. It works. Um, I'm gonna stop and restart. Get right into this. It's not that it probably is difficult. If you've done this before, it's not difficult to understand. I went 4 seconds over again. The other one, it does the same thing. Notice that it's the same range. It just keeps doubling, doubling. Um, I broke it down here. It's going every four, so it counts right here. e- every four that way it increments every four. That way you go through 32-bit registers. 32-bit registers. If I was doing by two, it'd be 16-bit registers. But this is 32-bit registers. Um, inside here, this is where you'd be reading and writing to the registers itself. If you were doing it, you'd be reading and writing inside. You'd put the command in here to write to the register and read back whatever you want to do. That's what you do. It's really easy. Well, for me, I'm sorry for some people. Okay, so here's the first state machine. This is the one that selects which address range you want to look at. Address range. Um, this is the second, uh, the second state machine inside, and this one address range goes from 00 to 100 00. So it goes 0000 through FFFF, and then you can keep extending it just by adding the numbers here. Just keep going. If you look at these numbers, it, it goes by two. 1, 2, 4, 8. It keeps doubling. 16, 32, 64, 128, 256. It just keeps doubling. The next one down here, you just double it if you want a bigger range. Then you double that number. Then you double that number. It just keeps doubling, and you get. If you look at this right here, I put comments in here that say how you know what you're doing. This number here is this number, 8200 in decimal. Decimal. This is hexadecimal right here. That's hexadecimal. I can show you with a calculator. Let me check my time really quick. It's not hard to do. If you have a, yeah, I do. Okay, it's right here. So if you decimal, hexadecimal, A1 and decimal is 161. So if 8200, 8200 is 33280, 33280 there. So that's how I did that. That's how I selected which register I wanted. And here's the next one, 8400, 3379. Check my time. Stop and restart. Okay, so 8400. And I select 8 because 8400 is right here. That's the register to be looking at. The next one will be 8001. So we'll just put it in here. We'll 8400. So 8400, 33792. Uh, the next one will be 8001. So it's 32769, 32769. That's how I index these. Just so you know that's what this that's the decimal representation of the hexadecimal number. Let's not restart. This 1, 2, 4. This is just indexing. It counts. It just counts up to 15, 0 to 15. Um, because there's 15. 0 to 15 for each byte. That's just why I did it that way, 0 to 15. If you dig into this and you had this and you wrote this, you'd see how it worked. I can't go through every detail of this. It takes a long time to figure it out. I'm just showing you it goes through each one by one. So this is how it does the addressing. This is how it does the data, and it goes to the what register you're going to write to, because this does the actual uh, main part of the address. This part right here does the lower end range of the address where you're actually writing the data